Okay, so it says find an exact value for sine cosine inverse of 4 over 5. So what we're going to do is, we don't know much about 4 over 5, right? It's not like one of our special angles. But what we can do is we can make a triangle. So say this is equal to some theta, this angle here. Then I can say the cosine of theta is equal to 4 over 5. And then I know a little bit about that. So here's my right triangle. Here's my theta. I know cosine is adjacent over hypotenuse. And so my adjacent side is over here, 4. My hypotenuse is 5. Then I can use the Pythagorean theorem to find that third side here, okay? So I can say, call this, let's see. I don't want to call it O. I'll call it X. X squared plus 4 squared is equal to 5 squared. There's the Pythagorean theorem. X squared is equal to plus 16 is equal to 25. X squared equals 9. So X equals either positive or negative 3, depending on what quadrant we're in, right? Okay, so cosine was positive. So we're either in the first or the fourth quadrant. They didn't really tell me, oh, I know I have to be in the first quadrant because it's inverse. Okay, so it was inverse cosine, so I've got to be in the first quadrant. All right, so X has to be 3 because I'm in the first quadrant. All right, there we go, problem solved. So now we can say, what's the sine of theta? So here's 3 for my X value. Okay, so I know my triangle now. I know all 3 sides, so I know all the trig functions if I need to know them. And what was theta? Well, we don't know. We could figure it out on a calculator, but we don't want to do that. We don't have to, because we're trying to find the sine of theta. We're trying to, all of this was theta, and so we're trying to find the sine of that. Well, the sine of theta is going to be opposite over hypotenuse. And so that's going to equal 3 over 5. And then that's going to be the answer. It's an exact value. I didn't need my calculator. I drew a triangle. You draw a lot of triangles in trig. Okay.